Hello students, welcome back. Let us start with a new chapter of your textbooks, Polynomials, and the topics to be covered are Introduction, Polynomials in one variable, Zeros of Polynomial, Remainder Theorem, Factorization of Polynomials, Algebraic Identities, and finally Summary. So to start with Polynomials. So what exactly polynomials are? So now this term polynomial is derived from two other terms. One is poly and the other one is nomials. Poly means many and nomials means number. So and the basic definition of polynomials, polynomials are expressions consisting of variables and coefficients then basic algebraic functions. So what are the basic algebraic functions that we know of? Subtraction, addition, multiplication. There also is division, but I'm not really taking into account right now. Okay, and their non-negative integer exponents. So this is the basic definition of polynomials, but in this definition there are so many hidden terms that we need to understand in order to understand what exactly polynomials are, starting with expression. So expression in layman's language, if I say that Rita looks happy today. So what are we talking about Rita today? That she looks happy. Happy is conveying what? It is conveying a gesture, it is conveying an expression of somebody's happiness. So how do you express in maths? In maths, algebra especially, see, you have numbers. Numbers could be 2, 3, 4, minus 4, minus 6 upon 8, so on. Okay, they could be fractions, they could be even mixed fractions like this, or they could be decimal points, 0.5 and so on. What about expression? Expression consists of a number of terms. So what is expressions? It is made up of many units where each unit is known as a term. So if I write 3x plus 4y, it is an expression because I have two units or two terms, they are joined together by a plus sign. This is similar to if you can say that Ram has 3 apples and 4 bananas in his tiffin box. So 3 apples and 4 bananas, they are present in a tiffin box. So this becomes an entire expression and these are the different terms. If I, let's say, write 30y minus 6z is equal to 22. So this is also an expression where you have 3 different terms. You have 30y one term, 6z as another term, 22 is another term, and here they are connected to each other by a subtraction sign and an equal to sign. So this is an expression. Now what about variables and constants? Variables, as the name suggests or the word suggests, they are values that are always going to keep changing. For example, if I just take a variable small letter x, today it could hold the number of eggs in a basket. Tomorrow it could probably hold the age or the population of a state. So this term here, x, is a variable. The value inside it could keep changing. For example, if you have a house over here, you can just name the house And if this house is given on rent, see, the location is not going to change, but the people who stay here are going to keep changing here. So x becomes the variable, that is, it becomes a placeholder, and constant is nothing but terms that are whose values are never going to change. For example, 2 is always going to remain 2, 3 will always remain 3, its value is not going to change. Okay, these are examples. So variables, coefficients, and then basic algebraic functions. So this was the definition here. Basic algebraic functions. The basic algebraic functions, mostly in cases of polynomials, we refer only to subtraction, addition, multiplication. We are not referring to division right now. We will learn why when we proceed with this chapter. And non-negative integer exponents. So what do you mean by exponent? First of all, non-negative integer means whole numbers. So this stands for whole numbers. So what is exponents? That means the exponents have to be whole numbers. If I write 5y square, this is 5 having variable y and it has a degree over here, right? It is raised to certain power, which is 2. So 2 becomes the exponent. If I write 5y minus 6 becomes an exponent, but here it is negative, right? So 5y raised to minus 6 is not a polynomial. Why? Because this is a negative integer exponent. And now these were simple, this was a simple definition of what your polynomials are. Now polynomials are further divided as monomial, binomial, trinomials. So polynomials are further divided as monomials, binomials, and trinomials. This is at the basic level. So when I say polynomials, within polynomials I have monomials. Monomials are nothing but polynomials that have only one term. For example, my monomial could be as simple as a number 2 or number minus 3.5, because here this is a polynomial. Why does this become a polynomial? 2 can be written as 2x raised to the power of 0. Anything raised to the power of 0 is 1. So here you have a variable, you have a coefficient, and you have a non-negative integer component, integer exponent, and this is one single term. So one single term here is your monomial. Monomials are nothing but polynomials that are made up of only a single term. Again, similarly, minus 3.5 can be written as minus 3.5y raised to 0. So this is a monomial again. And what if I have something like 1 upon 5x square? Is this a polynomial? Yes, it is a polynomial, because again it is one term made up of a constant, which is the coefficient. You have a variable and raised to a non-negative integer exponent. Then how about 3y raised to minus 6? Again I have a coefficient, I have a variable, but my integer exponent here is negative. So this is not a polynomial and it is not a monomial either. So basically a monomial is a polynomial that is made up of a single term. So binomial, what is bi? Bi, as the name suggests, it will have two terms. So I will have 2x plus y. This is a polynomial. It has two terms, right? Or you can even have 2x plus 6. This is also a binomial. It has two terms because 2x and 6x raised to 0 or 6y raised to 0. You can even have something like 36 plus 11y. This is a binomial. It has two terms. Then how about 11y square plus 2? Is this a polynomial? Yes, it is a polynomial because it has two terms. It is a binomial, therefore it is a binomial also. It has one non-negative integer exponent here, y square, and 2x raised to 0, y raised to 0. So again there are two terms. So this is a binomial, which is nothing but a polynomial with two terms. Then how about 36z cube plus 8y raised to minus 1? Is this a binomial? Most of you would say yes, but no, it is not a binomial, although it has two terms out here. Check out this number, y raised to minus 1. Minus 1 is a negative integer exponent, therefore this term is not a binomial. Similarly, trinomial would be a polynomial wherein there are 3 terms. So you can take something like this, 2x square plus y cube plus 1. This is a trinomial. Okay, and so on. So here we learnt about the different types of polynomials. At the basic level you have monomials, binomials and trinomials. Let's learn about degree of polynomial. Degree of polynomial is nothing but the polynomial in which the variable, the degree of the highest power of your polynomial. So if I write 3x square plus y is equal to 8 out here, what do you think is the degree of this equation? It is 2. If I have 36y cube plus 72x plus 9, what do you think is the highest number? What is the degree of this polynomial? Which greatest number are you going to consider? Are you going to consider 72 or you are going to consider y cube? You will consider y cube out here. Why? Because this is the highest exponent. The value of the highest exponent in your polynomial is going to give you the degree. Okay. So degree of polynomial is the value of the highest exponent. So if I am going to say please find the degree of this expression or this polynomial out here, the degree is 2. The degree of this polynomial out here is 3. So we learnt about polynomials, degrees of polynomials. Now the different types of polynomials that you can have depending, so the different types of polynomials. You have polynomials, you can form linear polynomials. Then you will have quadratic polynomials. Cubic polynomials. So polynomials are classified as linear polynomials, quadratic polynomials and cubic polynomials depending upon the degree of the polynomial in your equation. So a linear polynomial of a given polynomial is linear wherein the degree is always 1. Quadratic polynomial when the degree is 2 and cubic polynomial when the degree is 3. So over here, what do you notice? The degree of this polynomial expression is 2. Therefore, it becomes a quadratic polynomial. So one example is 3x square plus y is equal to 8. Cubic polynomial, an example is here because the degree of this polynomial is 3. So I have 36y cube plus 72x plus 9. What about a linear polynomial? A linear polynomial can have as many terms. For example, I can just write 3x plus y plus z plus a plus b. This is a linear polynomial because the highest degree is 1 for each of these variables. Even if I write 3x or minus 48y, the highest degree is 1. Therefore, this becomes a linear polynomial. So, irrespective of how many terms you have in your expression, if the degree is 1, then it is a linear polynomial. Similarly, irrespective of the number of terms, here you have 2 terms. Even if you would have had 3 terms like this, 3x square minus, let's say, y plus z is equal to 9, or just these 3 terms out here. There are 3 terms, but the degree of this polynomial is 2, therefore it becomes a quadratic polynomial. And here, even if I would have had something like z cube, this is just one single term which makes it a monomial. It is a monomial but a cubic polynomial. Got the difference? Here again, this is a trinomial but a quadratic polynomial. This one out here, it is a monomial, that is, there is just one term in this polynomial, but the degree is 1, therefore it's a linear polynomial. So I hope you've understood the basic difference between monomials, binomial, trinomials and linear, quadratic and cubic polynomials. There's a lot of confusion amongst most of the students because of these terms. So please get your basic foundation just clean, okay? And this is the degree of polynomial. So the degree of polynomial highly affects the different types of polynomials that we have: linear, quadratic and cubic. And now, having done this basic things about polynomial, we'll just take a look at a small topic, that is zero of polynomial. If you need to find the zero of polynomial, what you do is you just equate that polynomial to 0. Okay. So if I have a term, let's say 36x minus 3, and I need to find the zero of this polynomial, what I'm going to do is I'm just going to equate this term to 0. So this becomes 36x is equal to 3, x is equal to 3 upon 36. So 3 1s are 3, 3 1s are 3, 3 2s are 6. So x is equal to 1 upon 12. X is equal to 1 upon 12 becomes the zero of this polynomial. So this is how you usually go about finding zeros of polynomials. We'll take a look at in-depth details of zeros of polynomials and these other 3 remaining sections in the forthcoming lectures. But just so that you know, remainder theorem, factorizations of polynomials, algebraic identities, they are going to be a little tricky concepts, wherein remainder theorem would be more like when you factorize, you have the dividend, divisor, quotient, remainder. Similarly, for usually you use division for simple division. Like for example, you have 36 divided by 12. What you do is 36 and 12. So 12 3s are 36 minus 0, right? But if you have polynomial expressions where there are a lot of variables and coefficients, then remainder theorem will help us do the division. Similarly, factorization of polynomials will help you to split the factors. For example, if I have 36 again, so I have 4 9s are 36. So 4 and 9 are factors of this term out here, right? Because 4 will also divide 36, 9 will also divide 36. Then you even have 12 3s are 36. So these are also the factors. So using factor theorem, you will be able to factorize or find the factors of your given polynomial expressions, and we will also take a look at different algebraic identities, which will be more like addition, subtraction. You will see as we proceed with the chapter, and obviously the summary, which will be an overview. So this was about the introduction, and I hope you had fun while I explained you this introduction. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.